All right, so we're doing repeating decimals, lesson 30. Everybody should have a lesson 30. So let's begin. Okay, and we're going to start with the power up, which means you're going to help me do these as fast as you can. So everybody should have a scrap sheet of paper so you can do this. You can do it on your notes if you want to, but this is speed. We want to all participate and all have some speed. Okay. Ronald ran 7 laps of the park. What? 7 laps of the park in an hour. Enrique ran 4 laps in half an hour. Okay, so Enrique was faster because?
It's 8. Like 8 is bigger than 7.
Okay, so Enrique's speed was 8 laps per hour, right? Because she ran 4 laps in half an hour. 8 laps per hour is faster. Okay, so, ready? Rewrite and complete this congruent statement. Triangle ABC is congruent to WXY. Very good. Why do we have to have it in that order? Okay, you must mimic the order of the original triangle, don't you? Okay, so, very good. Jackie rode his bike 20 miles per hour for 1.5 hours. How far did he ride?
30.
30. Very good. You guys are on track. Because why? 20 times 1.5, right? So basically, it's the 20 times 1 is 20, plus 20 times a half is 10, and 20 plus 10 is 30. Very good. All right. 4.5 times 4 is? 18. And why? Okay, so 4 times a half. So basically 4 times 4 is 16, plus a half times 4 is 2. So you guys that aren't getting these as fast need to look at the reasoning here. Write 750,000 in scientific notation. Who can do that for me?
75 times 10. 10. Oh, wait, no, it's
7.5 times 10 to the 5th.
To the 4th.
To the 5th, yeah.
Okay, so how do we determine? We start at the end, which is where the decimal is, isn't it? And we're going to go 1, 2, 3, 4, 5 to get it after the first non-zero digit. So it's 10 to the 5th, isn't it? Yes, sir.
Can I take a picture of the thing?
Yes. You may take a picture very quickly and put it right away. Okay, Gina earned $24 in 3 hours. At that rate, how much would she earn in 5 hours? 40. Reasoning.
Because, like, 24 divided by 3 is 8.
So she's making 8 per hour.
And then it's like 8 times 5.
I thought it was
Okay. So she's making 8 per hour, and she's doing it for 5 hours, right?
minimum.
What whole number is closest to the square root of 101?
Like 11.
10. Thank you. 10 because what is the square of 10? 100. What's the square of 11?
121.
121. So isn't 101 much closer to 100 than it is to 101? Okay? Does everybody understand that reasoning? Okay, so 10 squared. So this is the way you would look at it. 10 squared is 100. And 11 squared is 121. Okay, so this is much closer to 10 than it is to 11. All right, here we go.
Oh, I was looking.
Come on, come on. Come on, guys, help me. Huh? In the packet? I don't know what you mean by in the packet. Oh, yeah, it's part of the package. Look up under Power Up.
I don't know why I don't know what I
It's 2. 8 divided by 4. I messed it up.
Come on. Start over. All right. Yes, it's 100. Okay, ready? 28 divided by 4 is? 7 plus 2 is? 9. 9 times 7 is? Plus 1. Square root it. 8 plus 5
13.
times 2
26.
minus 1.
29.
Square root it.
5.
Minus 3
2.
times 50.
100.
Oh, that was like an epic fail. Okay.
I messed up on the square root.
All right. So how we doing on time? Where's my time clock? Okay, we're doing good. Okay, so here are the starting up the new concepts. It says, recall that to express a ratio as a decimal number, we perform the division indicated. For example, to convert, excuse me, 3/4 to a decimal number, we divide 3 by 4. And when we do that, we say, okay, it goes 0 times 4 is 0. And then we bring down another, so we bring down the 3. And we bring down the 30, and then we go 4 into 30 is 7. We bring down the 28, right? And then we bring down the 2 and the 5 and the 0, and then 4 goes into 25 times. So that turns a fraction into a decimal. Also remember that the 3 dots that you see often, Mrs. A uses these way too much. I like ellipses. Okay, so it's called an ellipsis. It indicates that a sequence continues without end. Notice that we used a decimal point and zeros to write 3 as 3.00 so that we could perform the division. So any whole number, you might have to add some zeros to it to get it to where you can divide it. Some fractions convert to decimal numbers that have repeating digits, such as 0.272727 ... The repeating digits are called the repetend. I had forgotten that word. That's a good word, repetend. We can indicate repeating digits with a bar over the repetend. We write 0.272727 ... as 0.27 with the repetend bar over the repetend. Okay, so express each fraction or mixed number as a decimal number. So what shall we do? Shall we divide 1 divided by 6? And remember, this is your notes. You should be taking notes here. Okay, 1 divided by 6. So since I can't divide 1 by 6, I'm going to add a decimal and a 0. And since I have no decimals in my divisor, my decimal's just going to peek right up there. Okay, how many times will 6 go into 10? 1. So 1 times 6 is 6. And then I get a result of what? 4. And then I'm going to bring down, I can just keep on adding zeros, can't I, guys? I'm going to bring down a 4, and 6 goes into 40 how many times? 6, thank you. Okay, 6 times 6 is? 36. Very good. Okay, so now we're going to do what? Subtract and get a 4. Uh-oh, we had a 4 before. So that's going to turn into a 40 when I bring down another 0. And what is it going to repeat? 6. So I'm going to get 1.666, and it's going to keep on repeating. But I wouldn't put the repetend sign there. I would make it over the 6. So I would write that as 0.16 with the repeating sign over the 6 because that's the only digit. Okay, so if I extended it too far, that would mean the 1 is probably, I may have made it a little bit too far anyway because I'm not on a typewriter, but it should just go above the 6, not above the 1 at all. Okay, so let's look at 2 1/3. Who knows what the decimal value of 1/3 is? 0.33333, which 0.3 repeating. So who can give me a stab at this without us having to do the long division? How would you turn it into a decimal?
2.333.
Okay, 2 point, and since only the 3 is repeating, we'll put the line over just the 3, right? Okay, very good. Okay, so now this one was the first one that we did. Okay, this one was the second one that we did. All right, so it says recall that converting a rational number to a decimal form has 3 possible outcomes. The rational number is an integer. Okay, so a rational number is any number that can be written as a fraction. And some of those are integers, like 3 or 2 or 100. Okay, the rational number is a terminating decimal number. That means it ends, right? Or the rational number is a non-terminal decimal number with repeating digits. That's always going to be the case if the original was a rational number. Okay, so when I say rational number, is 3/4 a rational number? Yes, because it can be expressed as a fraction. That's what rational means. Ratio is the root word of rational. So if it is rational, it can be expressed as a fraction. So let's go backwards on this, guys. If a rational number can be a non-terminating decimal with repeating digits, or a rational number could be a terminating decimal number, so it ends somewhere, or a rational number could be an integer, then wouldn't the reverse be true? Wouldn't every repeating digit number be rational? And wouldn't every decimal that terminates be rational? And wouldn't every integer be rational? Okay, so if one is true, the other is true, right? So it says non-terminating, non-repeating decimals are irrational and do not result in converting a rational number to a decimal. Okay, so if we have a something that is irrational, it's going to end up non-terminating or non-repeating, or vice versa. If we have something that does not terminate, doesn't end, and does not repeat, then it is irrational. Okay, to perform calculations with repeating decimals, we first round the number to a suitable number of decimal places. Okay, so in other words, we need to get an approximation, a rounding, before we can do things with it. So here we go. It says find 5/6 of 12.47. Okay, so 5/6 is what? Let's first turn it into, now we could do this with fractions and leave it as a fraction and have it more accurate. Okay, or we can turn it into a decimal first. Let's see what they do in theirs. Okay, so basically they converted it. Now this is what they're wanting you to see here. They converted 5/6 to 0.83, and then they rounded that. It was 0.83 repeating, and then they put 0.83 because 3 is not 5 yet, is it? Okay, so they rounded it down, and then when they multiplied 0.83 times 12.47, they got $10.35. Okay, but then, okay, so we talked about if we change this to a decimal, then we end up getting $10.35. But Martha multiplied by 5/6, and she multiplied 12.47 times 5/6, which means she's going to do what? She's going to take 5/6 times 12.47 over 1. Okay, so she went ahead and did this whole multiplication first, and then she divided by 6, and she got 1039. Which answer is more accurate? Which one do you think is more accurate? All right, guys, which is more accurate? The one where you rounded at the beginning of the problem, or the one where you rounded at the end of the problem? Which do you think is more accurate? What are they going to round on this problem? Aren't they just going to round right here in the, they're going to round that last digit, right? Because they're rounding at the very end of the problem. Which one would you bank on being more accurate? Come on, guys. Okay, well, she estimated $10.39 over $10.35. Which one is more accurate? Which one is closer to the real answer? Isn't it closer to do the problem exactly?
Yes.
And then round at the end than it would be to round at the beginning and then do the problem? Okay, now that's why this is important. I want everybody to listen. If you are on a test and you are told to round the repeated decimal at the beginning of the problem, then they're going to expect you to give this answer. But if they do not tell you to do that, they would expect you to give this answer. So you'd better be careful which directions. Are you supposed to do it with a fraction and then round at the end? Because we've been doing this kind of problem for a long time, guys. We've been doing this as a fraction, and we've been getting a more accurate answer. But they're saying when you're working with decimals, you are going to end up rounding before you do it. You're going to wind up with a little bit less accuracy. Okay? So, arrange in order from least to greatest. So who knows which one is the least? Which one is the least, Alexa?
Wait, which one would it be? Least to greatest, going from least to the right or least to the left?
Least is left, greatest is right.
0.3.
Okay, so 0.3 would be first.
Then 0.33.
Okay, because,
Because the middle one has a line where it's repeating.
okay, so this one right here
Never ending.
is never ending. So it's 0.3333. And so basically when you're looking at the 0.3 has a 0 in the hundredths place. Okay, and then once you compare that, then you're looking at the thousandths place. This still has a 0. This still has a 0 in the thousandths place, but this one has a 3. Does everybody see that? Okay. All right, so basically they're showing you, see how they're expanding these numbers? 0.3 is 0.300, 0.3 repeating is 0.333, and 0.33 is 0.330. Okay, so they expanded each one out to the thousandths place to make that decision. All right, many calculators do not have functions that enable the user to perform arithmetic with fractions. To convert a fraction to a decimal, we enter the numerator, press the division key, and then key in the denominator and press the equal key. So we would, on our calculator, type in 10 divided by 11, and then we would type in 11 divided by 12, and we would type in 17 divided by 80, okay? Now, a lot of you don't have a calculator, so I'm going to drum up a calculator. Uh-oh, I moved that right in the middle of it. So I'm going to, what was the first problem? I lost it. Did you lose it? So 10 divided by 11 was the first one. Okay, so we're going to come to our calculator, type in 10 divided by 11. Oh, I hit pi. I can't see, guys. Okay, let's go ahead and see what that is. Okay, so now we're going to clear that. Where's the clear? Do you see a clear?
All clear.
Where's the clear? I can't see the thing. Okay, where's the clear?
Right there.
Okay, all clear. Okay,
So
10
you
divided
want-
by 11. Divided by 11. Oh, okay. Good job. All right, so 90, 90, 90, 90, 90, 90. Okay, so if we were going to write that, let's go back over here to our, our calculator. Point 9090. So where is our lesson? Okay, so here we've got on here 0.9090 over and over and over. So how would we write that most succinctly? 0.90 repeating. Now, is that 0 important?
No.
Yes. Yes. If we just did 0.9 repeating, it would be 0.999999. So we have to include. Okay, so now we're going to do 11/12. So let's get rid of that, and we're going to do 11. Okay, yes.
Use tax support again.
Yeah, please use that support.
There you go.
Okay, 11 divided by
Yeah, please
12. Huh?
11 divided by
I was trying not to let you go.
12.
Yeah.
And
Strong
then
said no.
equals.
Okay, 11 by 12. Okay, so that's going to be what?
0.916 repeating.
Okay, 0.916 repeating.
We got to put the repeating over the 6.
Okay. 0.916 repeating. Okay.
Not over the 1, just the 6.
Okay, yep. That does look a little confusing. Let me make it a little smaller. Okay, so we're going to just do it over the 6. Now we're going to go and do the last one, which is 17 divided by 80. So I'm going to do, I think maybe I can do it. Let's see. So we're going to do 17 divided by 80. What was it? Let's try 80. 17 divided by 80.
Nope. It's
0.212. Okay, so that is terminating. Okay, so let's put this back here. See if we did the right one. 17 divided by 80. Yes. So 17 divided by 80 is 0.2125. So that one is 0.2125. And it is not repeating. So that is the terminating one, isn't it? Okay, so here we go to the next one. So it says to add fractions, it is not necessary to enter long repeating decimals, and it is not necessary to round the decimal equivalents. For example, to add 5, 6, and 8/3 on a calculator that has algebraic logic, which means it follows the order of operations, we can use this keystroke sequence. 5 divided by 6 plus 8 divided by 3. Because what's going to happen? The calculator is going to use order of operations, and it's going to do 5 divided by 6 first, and then it's going to go do 8 divided by 3 first, and then it's going to end up adding the two together. Okay? So here it says if your calculator has algebraic logic, the final display should read 3.5, which equals 3.5. Try these operations and find the decimal result. Okay, so basically they're saying this one should have been 3.5. So let's check it. So this one is supposed to be 3.5. Let's do it with fractions first. 5 divided by 6. And then this one was plus 8/3. But we would change 8/3 to what?
16/6.
Okay, so we're going to change this to 16/6 because I'm getting what? A common denominator. So then 5 plus 16 is 21/6, which divide by 3 is 7/2, which is 3.5, isn't it? Okay, so now let's try this on our calculator and see if our calculator has order of operations here. We're just going to try it and see. We're going to hit all clear. So we were doing, what was our problem? Somebody remind me. 5 divided by 6 plus 8 divided by 3. So 5 divided by...
You did put all clear.
Oh, I didn't click all clear. Okay. 5 divided by 6.
You didn't click the divide. Hit backspace.
Oh, I didn't? What did I do? All right.
Tech support.
Okay,
this
so
should-
let's, okay, start over. Let's
5.
clear.
5 divided by,
I'm wondering if it's
What?
just not working.
oh, it could be this
Because
is in
it's
the way.
in the way. Here, we can
Yeah.
move that to the top.
Oh, that works too.
Divided by
Yep. 6.
plus, plus,
I'm not sure if that
8.
works, but
divided
try.
by 3. Now, we're going to see if it does work.
it does.
3.5. Okay, so this one has the algebraic logic. This one is doing the... I know, awesome, right? Okay, so now the next one that we're going to do, let me get this back in the frame. The next one that we're going to do is this one. Okay, 11/12 plus 11/6. Okay, so no, this is not practice. So we're going to do 11/12 plus 11/6. So let's go here and we're going to do 11/12. So we'll just have 11 divided by 12 plus 11 divided by 6. All right? And what do we get? 2.75. So we're going to come over here and, oops, we're going to write 2.75. And get our pen. 2.75. Okay, so now we got to do the last one here. Now, these are not our practices yet. This is just showing you what you're going to end up doing. And, of course, when you're doing this on your homework, you're going to have to do it with a calculator, aren't you? Okay, now let's see. 17/24. If I were going to do it out, 1/2 would be how many 24ths? 12/24. So what's our answer? 5/24, isn't it? Our answer should be 5/24. So let's approximate. That's going to be about 1/5. If we change the 24 to 25, that would be about, so we're going to do approximately, we're going to give ourselves a guess, approximately 0.2, because that's what 1/5 is, okay? So let's see what it is really. Okay, somebody remind this, 17/24 minus 1/2. Okay, so let's go to the calculator. 17/24.
Yep.
So 17 divided by 24. And this is,
That's 25.
am I done? Minus?
That's 25.
Okay.
That's
Oh,
25.
I did 25. Okay, so we're working on this one right now, and we did it with fractions, and now we're going to do the same one using the calculator. When we did it with fractions, we got 5 over 24, which if we change that 24 to a 25, we would get 5 25ths, which would be 1/5, which would be exactly 0.2. So basically 5 over 24 is going to be very close to 0.2. So let's see what we get when we use the calculator. So I'm going to come over here to our calculator, and remember we're doing 17 over 24. So I'm going to type in 17. First I got to click on this. 17. And then I'm going to, well, let's click on this. 17 divided by, so I'm going to use my division sign, 24. And this is a minus problem, so minus, and then 1/2. So 1 divided by 2, and I'm going to enter, so click equals. I'm going to have to move this one up a little bit to click equals. Okay, 0.2083 repeating. Now remember I said it was approximately 0.2. So we're going to put a repeating symbol over the 3. 0.2083 repeating. So now we're going to write that here. 0.2083 repeating. And let's go on to the next one. Okay, it says many calculators do not have a percent key. To find a given percent of a number with a calculator, we mentally shift the decimal point 2 places to the left before we enter the number. So it says estimate 6.2% of 72.59. Then use a calculator to perform the actual calculation and round the answer to the nearest cent. What decimal number did you enter for 6.25%? Okay, so first it says to estimate. So we could change this 0.59 and we could say, okay, well that is bigger than 72, so we'll make that 73 because we're just estimating. And 6.25% would be close to, now let's first of all, let's get a good approximation. Let's say that we're going to move that decimal 2 places to the left to take care of the percent. So that decimal is 0.0625. So if we're approximating, let's make this 0.06, and then we'll multiply, because it's of, we'll multiply by the 73 to get an approximation. So we're going to have 73 times 0.06, which will, 3 times 6 is 18. 7 times 6 is 42, plus 1, 43. Now remember, our decimal is here, so we're going to move it 2 in. So our approximate is 4.38. And that is in money because of the dollar sign there. So we're going to say approximately. So this was probably a tax. Okay, 6.625% is probably a tax right there. So we could say that would be $4.38 approximately. It says then use a calculator to perform the actual calculation and then round to the nearest cent, because we always would. What decimal number did you enter? So we already know what decimal number we're going to enter for that. Okay, so we're going to take 0.0625 and multiply it by 72.59. Okay, so let's come over here to our calculator, and we got to clear that out. And I'm not sure why it's not looking cleared, but let's try that. So we're going to put, the number was 72.59, 72.59, and we're going to hit times, and we're going to use 0.0625 because that's the decimal equivalent of 6.25%. And we get 4.536. So if we're going to round this to the nearest tenths, that's going to become a 4, isn't it? Because the hundredths for money. So that 6 is going to make that 4.54. So let's go over here and we'll say 4.54 would have been the actual 6 1/4 tax. So we didn't do so bad with our estimation. It sure did make the calculation better. Okay, so we were, what, 16 cents off of what the actual tax would be. Okay, so that wasn't too bad. All right, so now we're going to start our practice set. And it says write each fraction. Let's see if I can get rid of this here. Okay, write each fraction in A through D as a decimal number. Okay, so we're going to do each one of these, but I did prepare a separate slide for each. So we're going to do 3/11ths first. And, okay, so I've got all of this stuff over here. We're just going to have to ignore all of that because I don't have it in play mode, but that's okay. So we're going to say 3/11ths. Now, if I'm going to change it to a decimal, I'm going to do 3 divided by 11, which means I'm going to have to put a decimal 0. And let's go ahead and put another 0 while we're at it. Okay, and we're going to have 11 into 30 is going to go 2 times, because that would be 22. 2 times 11 is 22. And then we're going to subtract and get 8. And bring this down. This is now a 2, isn't it? So 2 minus 2. We'll bring down the next 0. 11 into, and I remember our decimal is right here. So 11 into 80 is going to go 7 times. 7 times 11 is 77, which will go there. 77 from 80 would be 3. And guess what we started with? 3. So let's carry out one more time. 11 into 30 is going to go 2 again, isn't it? And we are starting all over again. So it's going to be 0.2727, and we would write that as 0.27 repeating. Okay, now this 3/11ths is rational. Remember, we're guaranteed that every rational, because this is a ratio, every rational number will either be an integer or a decimal that ends or a decimal that repeats. And so we have found the repeating decimal that is equivalent to 3/11ths. Okay, so let's look for the next one, 2/9. Now, I love dividing by 9s. Okay, so let me show you a little trick. 2/9 is the same as 1/9 doubled. Okay, so if you learn what 1/9 is, this is going to save you a lot of time. So let's look at 1/9. 1 divided by 9. I'm going to put my decimal and my 0. Okay, so 9 into 10 goes 1 time. 1 times 9 is 9. And I get a 1. Well, I started with a 1. So I'm going to bring down another 0. 9 into 10 goes 1. And I get another 9. And guess what? It keeps on going forever. And I'm going to have point, because my decimal rises right above the old decimal, 0.1111111. That's what makes 9 so nice. Because if 1/9 is 0.11111, then wouldn't 2/9, which is 0.11111 times 2, be 0.222 ... which is going to be 0.2 repeating. Now, the cool thing is, what's 3/9? 3/9 is 0.3 repeating. 4/9 is 0.4 repeating. 5/9 is 0.5 repeating, and so on and so forth. So because it's just 0.11111 or 0.1 repeating, I can multiply that, and that works all the way up through your digits. So basically, 8/9 would be 0.8 repeating. Okay, now 9/9 would be 1 whole. Okay, so that's where it would stop at 9/9. That's 1 whole. So that is a cool thing, though. Remember, this is 3/9 is 0.3 repeating, but we also know that 3/9 is 1/3. So if you remember the 9ths rule, you'll also remember that 1/3 is 0.3 repeating, won't you? Okay. All right, so now we've got 2 and 2/3. Now, because I'm changing this into a decimal, this 2 is going to go in front of the decimal. So 2 point, now all I have to do is worry about the 2/3. And again, I can save myself a lot of trouble. I could divide 2 by 3, or I could remember that 2/3 is equal to 1/3 doubled. 1/3 times 2. And we just talked about what 1/3 was. 1/3 is 0.333333, or 0.3 repeating. So if I had 0.3 repeating, and I was going to multiply that by 2, wouldn't that be 0.6 repeating? Okay, so 0.6 repeating. Now, if I had done this, 2, I'm going to put decimal, 0. 3 into 20 is 6. Decimal goes up above. 6 times 3 is 18. I subtract, and I get another 2. Well, I started with 2. So I'm going to get 0.6 repeating. And so you could divide it out, or you could remember that 1/3 is 0.3 repeating, so 2/3 would be double that, or 0.6 repeating. So this would be your answer. So like most of math, there's a smarter, easier way to do it, and there's a longer, harder way to do it. Okay, so choose the smart, easy way anytime you can remember it. Okay, so now 1/30th is, now let me ask you this. Remember, when we divide by 10, don't we just move the decimal? I know what 1/3 is. 1/3 is 0.3 repeating. Okay, so if I had 0.333 and ... which is 1/3, and I wanted to divide it by another 10 because I have another 10 on the denominator, then wouldn't that just, see, that's 0.3, wouldn't that move that one step over to the left? Remember when I divide by 10? And I would get 0.03 repeating. So, okay, so we got here and we said that 0.303, click on that, see if I can get back. Oh, we'll use a different color. Okay, 0.03 repeating because 1/3 divided by 10 is the same thing as 1/3 times 1/10, which is what we're looking at, right? We're looking at 1/30th. So since 1/3 is 0.3 repeating, and we're going to divide by 10, that means we're just going to move that decimal place one place over. And of course, if you want to do the long division, it works the same way. We would do 1 divided by 30, and we'd put a decimal and a 0, and the decimal would go there, but 30 doesn't go into 10, so we'd put a 0, and then we would bring down another. Okay, and we would get 30 into 100 would go 3 times. 3 times 30 is 90, which would leave us with 10 again. Okay, then we'd put down another 0 and we would have 0.33333. Okay, so whether you do it by understanding it's 1/3 divided by another 10, or whether you do it out the long way, you should get 0.03 repeating. Okay, so this is, remember, we're doing your practice, so you should be doing these on your sheet. Round each decimal number to the nearest thousandth. Okay, now remember, to round it, we're going to put we're always going to go 1 decimal more than needed. So there's the thousandths place right here, tenths, hundredths, thousandths. So we're going to go 1 more place before we round. So since 3 is less than 5, we're going to round it down to 0.333. Okay, so then we're going to take 0.666. We're going to go 1 step more, 1 step past the thousandths place. We're going to look at that 6 and say, oh, that's more than 5. So we're going to round this one up, and the answer would be 0.667. Okay, and then this one, we've got to keep up the pattern, 0.3636. So we're going to go 1 place past the rounding spot. Since this is a 6, it's going to round this one up to a 4. So we get 0.364. And then this one is 1.8686, carrying it 1 place past the thousandths place. This is a 6, so that's going to round this one up. So I'm going to get 1.869. Those are fun. Okay, so you know what? I did that all on that sheet, so I'm going to skip these 3 slides because each one was just doing what I just did there. Okay, so now arrange in order from least to greatest. So now we're going to have to make sure that we take each one of these out past the hundredths place. So we're going to take each one of these to the thousandths place so that we can see the difference. 0.600 is this one, right? And then this one is 0.666 because it's repeating, and this one is 0.667. Okay, so we can see that this one, 600, is less than 660, which is less than 666. So to get them in order, we're going to put this one is the lowest because I put these in order, right? Okay, so this one is the least. Okay, this one is the greatest. And this one is the middle, isn't it? So now I'm going to put them in this order. So the least is, remember I go back to my original numbers. Okay, 0.6. And then the greatest is 0.6 repeating. That was the middle one. So this one's going to be over here. So 0.6 repeating. And then the last one was in the middle. So 0.66 goes here. Okay, so comma, comma. And so 0.6, 0.66, 0.6 repeating, because that's going to be 0.66666. All right, so I did that one on a different slide. So let's go do this one, J, on a different slide so that we have a little bit more room. So now we have no negative numbers. So we have no 0. So all of these are positive. All right, so I'm going to put them all into a decimal form. And let's think about how far I need to go. I need to go out to thousandths place. So I'm going to go out 3 decimal places. So 1/2 is 0.5. But I'm going to put 0.500. Okay, and this one is 0.555 going out to the thousandths place. This one is 1/3, so that's 0.333 out to the thousandths place. Okay, so let's draw a little line that's going there. And then this one is 0.3, but no repeating, so that's just 0.300. And the last one, so it's going way over here, is 0.066. Okay, to the thousandths place. I'm just going to keep on repeating it. So now once we've carried them each one to the thousandths place, we can see which one is the greatest. Okay, and which one is the least. So when I'm going to put these in order, I want to go with the least one, oops, which is this one right here, because it's got 0/10, 3/10. Okay, so we're always going to choose the place value that has the first change in it here. So 0.066 is the least. So this one is the smallest. We'll put this down as number 1. Okay, because it's the smallest. And we have 1, 2, 3, 4, 5 numbers. So then we can look at what is the greatest. Okay, the greatest would be this one right here, wouldn't it? This one would be the greatest. So that's 0.5 repeating. So I'm going to put a number 5 on that because that's greatest. Okay, and then the going from this one, 0.3, that's going to be the next smallest from this one. So 0.30 is number 2. 0.333 is number 3. Number 4 is 0.500. And that gives me the order that I'm going to write them in. So I'm going to write them 0.06 repeating, comma, 0.3, comma, number 3 is 1/3, comma, 4 is 1/2, and 5 is 0.5 repeating. Okay, now we're going to start our written practice. Number 1. Okay, so we're doing example 1, and we are, okay, so there are 20 students in the algebra class. 1/2 of the students were boys. 1/2 of the boys wore t-shirts. How many boys wore t-shirts in the algebra class? Boys wearing t-shirts were what fraction of the students in the class? So there were 20 students altogether. Okay, so 20 students were in the algebra class. 1/2 of the students were boys. So that means that boys were 10. Okay, and then 1/2 of the boys wore t-shirts. So boys wearing t-shirts were half, so that would be 5. How many boys wore t-shirts? So that's 5. Boys wearing t-shirts were what fraction of the students? So 5 out of the total number of students, which was 20. Okay, but we wouldn't leave it 5/20ths. We would divide by 5 on the top. We would divide by 5 on the bottom, and we would get 1/4. So the answer to number 1 is 1/4. Okay, number 2, the big room measured 19 feet and 10 inches. Okay, and 22 feet, 1 inch. Okay, about how many square feet of carpet are needed to recarpet the room? So they did say the word about. Okay, so we would say, let's round. 10 inches would only need 2 more inches to make another foot. So let's go ahead and round this to 20 feet. Okay, and 1 inch is not going to round up, it's going to round down. So we're going to say that's 22 feet. So now to get square feet, now remember if they had said square yards, we would have to do a little bit of converting, but they said square feet. This is in feet, this is in feet. So 20 times 22 will be 2 times 22 with another 0 tacked on. So that's going to be 44 with another 0 tacked on, or 440 square feet. 440 square feet is the square footage of the room. Number 3 says the 4 pencils in Julio's desk have these lengths: 7.5 inches, 5 3/4 inches, and 5 inches, and 2 3/4 inches. What is the average or mean length of the 4 pencils? So we have 7.5 plus 5. Remember 3/4 is 0.75. And here's just 5. And then this is 2 3/4, which is 2.75. Okay, so I'm going to make everything have tenths places. So let's go ahead and say hundredths places. 7.50, 5.75. So I'm going to try to add these over here. 5.00, 5.00, and 2.75. So I'm making them all have the same number of digits. I could have done this in fractions. It would have been very easy to do in fractions, maybe even easier. But let's do this. 5 and 5 is 10, so I'm going to put a 0, carry the 1. And 6 plus 14, 7 and 7 is 14, so 6 and 14 is going to be 20. Carry the 2. and I have a 10 and a 9 and 2 more, so 21. Now, I'm not done. That's just my sum is 21. So I'm going to divide 21 by 4 pencils. Okay, 4 into 21 is going to go 5 whole times, which gives me 20. And 1/4 pencil left. So 5 1/4. So since we started out with fractions, we should leave our final answer in fractions. So 5 1/4 would be just perfect. Number 4. Find the area of the triangle. Dimensions are in millimeters. So area will be square millimeters, right? So we can go ahead and put that down. So now we've got the height is 4. The base is 5. And remember, area is 1/2 base times height. So we multiply base times height, and then we take a half. 4 times 5 is 20. Take a half of that is 10. So we have 10 square millimeters. Moving on to number 5. Classify the triangle in problem 4 by angles and sides. If each acute angle measures 26 1/2 degrees, then what is the measure of the obtuse angle? Okay, so first of all, we have to classify the triangle by angles and sides. So let's go back. Classify by angles, and angles would be, here's an obtuse angle. So we would say obtuse. Okay, so since it is obtuse, let's go look at the sides. We had a side of 5 and a side of 5. So since we have two sides that are the same, wouldn't that be isosceles? So we would say obtuse isosceles. Okay, and so now we have classified. Now it says if each acute angle measures 26 1/2 degrees. Okay, so let's go back here. 26 1/2 in here. This is 26 1/2. 26 1/2 degrees. And guess what? This one over here is also 26 1/2 degrees. So then they're saying, what is this obtuse measure if we have a 26 1/2 and another 26 1/2 over here? Well, 26 plus 26 is 52, okay, plus a half and a half would be 53. So the sum of these two, when we put them together, are 53 degrees. We know there are 180 degrees in a whole triangle. So 180 minus 53. So let's go over to the right page and do that. 180 minus 53. Okay, so that's going to be 7, 10, 7 to 127 degrees is the measure of the obtuse angle. 127 degrees. And number 6, the $80 DVD player is on sale for 25% off. Find 25% of 80. Now, I could say 25% is 25 1/100ths, which I know is 1/4. So 1/4 of 80 is simply $80 divided by 4, which is $20. I like to do things as easily as possible. Okay. And what is the ratio of a side length to the perimeter of a square? Okay, so the ratio, let's look at a square. Okay, now remember a square is the same side. So we're just going to make side, side, side. And the perimeter would be 4 times the side. And the side length would just be one side. So the ratio of a side length would be side to 4 times side. The sides would cancel, leaving a 1. And the ratio would be 1 to 4. Or 1 to 4 is the answer. And we are done with lesson 30. And I hope that you understand it all well. This is Mrs. A, and may God bless your day.